This video is going to go over several examples of writing a quadratic equation when you know a vertex and a point that the quadratic equation should go through on a graph. To do this, we're going to need to know vertex form of a quadratic equation. If you don't know that already, please go watch a video or look it up in your textbook before you move forward with these problems. Vertex form of a quadratic equation is y equals a times the quantity x minus h squared plus k. In this case, h comma k is the vertex of the graph. So if we're given a problem with a vertex at -2, 5, we can start by saying y equals a times the quantity x minus the x value of the vertex. And in this case, that's going to say x minus a -2, so we'll actually have x plus 2 quantity squared, and then plus the y value of the vertex, which is 5. So we know so far that y equals a times x plus 2 squared plus 5. And the final thing that we need to figure out is what this a value is. To do that, we're going to use the point that we know. We know that the point -4, -3 should satisfy this equation, which means that if we plug in -3 for y and a -4 for x, that this should come out to be a true statement. So there's only one value for a that will make this valid. -3 equals a times -4 plus 2 is -2 squared plus 5. -2 squared is 4, so we have a times 4 plus 5. I'm going to subtract 5 from both sides. We'll get that -8 equals a times 4 or 4a. So if -8 equals 4a, dividing by 4 on both sides, -2 must equal a. So if a is -2, that means the general equation for our quadratic is y equals -2 times x plus 2 squared plus 5. If you wanted to write that in standard form, or if you were asked to write that in standard form, you would multiply out the x plus 2 squared, okay, and distribute it into standard form. So I'm going to do that as an example here. That would be y equals -2 times x plus 2 times x plus 2 comes out to x squared plus 4x plus 4. Okay, we still have our plus 5 out back. Simplifying this, which means distributing the -2 and then adding 5 in with the constant term, we'll get -2 x squared minus 8x, and then -8 plus 5 is -3. Okay. I have the graph here of the two original points that we were given, the vertex and the point, so we can get an idea of what this looks like and see if it makes sense with the equation that we got. So because the axis of symmetry goes through the vertex, we know that this point here at -4, -3, okay, there's a point that's symmetric to it on the other side of the axis of symmetry. So since this point was 2 units to the left of the axis of symmetry, I can go to the right 2 units from the axis of symmetry and know that there's another point here. Our parabola is going to open down, which makes sense with the equation we got because we got a leading coefficient, or an a value, that was negative. So if you're asked to write the equation in vertex form, it's this, -2 times the quantity x plus 2 squared plus 5. And if you're asked to write it in standard form, you need to multiply out the quantity that's squared, distribute the a value, okay, and simplify the constant terms at the end. But those are both an equation for the same parabola. One is in vertex form and one is in standard form. Our next example says that the vertex is at 4, -5, and we have a point at -3, 1. So again, we'll use vertex form. Y equals a times the quantity x minus h squared plus k, where h comma k is the vertex. So we need to have y equals a times, well, x minus h, in this case h is 4, so x minus 4 squared, plus k. In this case, k is a -5. So we're going to actually write -5 at the end, right? Because plus -5 is the same thing as subtracting 5. And now we need to solve for the a value. So we're going to plug in the point we know that this equation has to satisfy, remembering that -3 is the x value and 1 is the y value. So 1 must equal a times the quantity -3 minus 4 squared minus 5. Well, -3 minus 4 is -7. -7 squared is 49. So a times 49 I'll write as 49a minus 5. Add 5 to both sides. 6 equals 49a Dividing by 49 on both sides, we get that a equals 6/49. That means that in vertex form, our equation is y equals 6/49 times x minus 4 squared minus 5. And it makes sense that our a value is positive because our vertex is down here and our point is up above that, which means our parabola opens up. That point is 7 units to the left of the axis of symmetry, so if I go 7 units in the other direction, there's a point over here, which means that our parabola looks something like this. It has that vertex at 4, -5, and it opens up. Again, if you wanted to write this in standard form, or were asked to write it in standard form, you would multiply x minus 4 times x minus 4, distribute out the 6/49, and then subtract the 5 from the constant term. Our third example has a vertex at 2, -4. So we'll take our vertex form and plug in the h and k values from the vertex. Y equals a times x minus 2 squared minus 4, okay, because our k value was a negative number. Then we're going to use the point 3, -1 to figure out what the a value is. So -1 equals a times 3 minus 2 squared minus 4. 3 minus 2 is 1. 1 squared is 1. So we just have a minus 4. Adding 4 to both sides, we get that 3 is equal to a. So our answer here in vertex form is that y equals 3 times the quantity x minus 2 squared minus 4. And if you wanted to put that in standard form, would come out to y equals 3. Squaring that, we get x squared minus 4x plus 4 minus 4 out back, right, from the plus k value. Y equals 3x squared minus 12x. 3 times 4 is 12, but then minus 4 would get us a value of 8 for the constant term. So in standard form, y equals 3x squared minus 12x plus 8 is the equation of this parabola. And in vertex form, it's y equals 3 times the quantity x minus 2 squared minus 4. Our next example has a vertex at -2, 3. So we'll have y equals a times the quantity x minus a -2 squared plus -3, so minus 3. So y equals a times x plus 2 quantity squared minus 3. Then we need to find that a value by using this point. So y is 25, a is the unknown, and -4 is x plus 2 squared minus 3. 25 equals a times -2 squared, because -4 plus 2 is -2. -2 squared is 4, positive 4, so we have 25 equals 4a minus 3. We'll add 3 to both sides, 28 equals 4a, and dividing by 4 on both sides gets us that a is equal to 7. So in vertex form, our equation is y equals 7 times the quantity x plus 2 squared minus 3. And in standard form, that comes out to 7x squared plus 28x plus 25. Given that our axis of symmetry is here at x equals -2, there's a point at -425. There's also a point at 0.25, and I can actually read that from standard form here, because if I plugged in 0, 7 times 0 is 0, 28 times 0 is 0, we get a 25 for our y value. So this is a tall, skinny parabola that opens up with its vertex at -2, -3. Last but not least, we have a vertex at -3, -13, and a point at 0, -4. Y equals a times the quantity x minus a -3 squared minus 13. Okay? Remember our h value and our k value. So we know so far that y equals a times the quantity x plus 3 squared minus 13, and now we need to calculate that a value using this point. So y is -4, x is 0, and now a is the only unknown we have left. So -4 equals a times, well, this is 3. 3 squared is 9, so 9a minus 13. We'll add 13 to both sides. On the right, that cancels. -4 plus 13 is the same thing as 13 minus 4, which comes out to +9. So 9 equals 9a, and dividing by 9 on both sides gets us that a equals 1. So our final equation is y equals 9 times the quantity x plus 3 squared minus 13. And in standard form, that would be y equals 9x squared plus 54x plus 68. And on our graph, our axis of symmetry is here at -3. So this point, okay, is 3 to the right of the vertex is 3 to the right of the axis of symmetry. So if we go 3 to the left, there's another point here. And we know that this should open up, right, because our a value was positive, and it does according to our graph. So it's a rough check of our work that tells us that we weren't completely off track. So in these problems, you can be asked to either write this in vertex form, okay, or in standard form. But either way, given the information you have, you want to start with that vertex form, y equals a times the quantity x minus h squared plus k, where hk is the vertex.